Hello everyone, so this is our submission for the GenAI Intensive 2025 Capstone project, and our project title is ScholarSense. That is basically an AI-powered research paper assistant that can interact with any academic papers, scientific papers, or any academic books out there by providing some functionalities like it can summarize those papers or books, generate flashcards, extracting key insights, evaluating student answers, and lastly we implemented RAG to see how the retrieval things works. So first thing first, we initialized the Gemini SDK. Then we created the Google API key from this website, Google AI Studio, and utilized it using the Kaggle secrets. And then we loaded our document. This is the paper. This is the paper titled Who Becomes an Inventor in America, the Importance of Exposure to Innovation. And what we did, we extract all the texts from that PDF and stored all the text in this variable, and we print the first 1000 character to see how it actually looks. And this is the main pipeline. So as we can see, we use the Gemini 2.0 Flash model, and we ask something like from the model, and we'll get response. And where the response will come from? So the response will come from this knowledge base, like the PDF we fed in. So this is the most important function here. The function has two things. One is request, basically the question the user will ask, and the document text, basically the knowledge. And we modified the generation config function by setting the temperature 0 because we want the model to be very deterministic. So we set the temperature to 0. Then the use case things, like the user asks the model something like summarize the document for a researcher who is trying to know what is discussed in the paper. So this is a question. So this question will go through the model, and the model will generate a response based on this knowledge base. So same thing, the user asks something, the thing will go to the knowledge base function, and then the output comes in. Okay, so this is one use case. The second use case is we defined or we specified a JSON format, like create 5 structured flashcards based on the research paper in the following JSON format. So we defined a JSON format, and now the model will return the response according to this format. So here are other use cases, like you are a helpful AI assistant trained to read academic research paper. Given the following paper content, extract a structured summary in this JSON format. So we provided a structured JSON format, like we want title, objective, method, findings, limitation, future work. So based on this format, the model will return a response following this prompt. So other use case, like now we want the paper type. Is it empirical, theoretical, survey, experimental, review paper? We defined a structure, and based on the structure, the model will generate a response. So for educational purpose, suppose we want something like 5 or 7 key technical terms or the glossary terms from a particular paper, particular academic books, or particular scientific papers. Then we specify the thing, we defined a structured prompt, we defined a format like term and definition, and based on this, the model will give you the same response as you have asked for. Okay, so the same here, we defined a scenario, like we defined a paper, like here what we did, you are a academic summarization assistant, your job is to extract key structure field from papers. Okay, so here we gave example, like we defined a title for a paper like understanding transformer. So this is for transformer papers. The objective here to analyze the inner working of self-attention, so blah blah blah. And what we want something like this. So it will analyze your paper and return something based on this example. So yes, it actually did the same. So now we want to evaluate the student answer, like we fed a book, academic book, maybe a scientific paper, and the student answers something by reading that paper. Okay, so suppose the student read this paper and the student's understanding is this: the paper proposes a method to improve attention mechanism in transformer. Okay, so this is the understanding of that student, and now we want to evaluate is this understanding is correct or not. So that's why we structured or crafted a prompt, and we want that the score out of 5, completeness, like is it complete, partial, or inaccurate, and feedback. So yes, the student said the paper proposes a method to improve attention mechanism in transformer. So our paper doesn't have any direct connection with transformer, so it is partially true. That's why the model gave a score 3 out of 5 and completeness partial and gave a feedback. Okay, and now we added one more thing, like the student answer, the quiz question, and the correct answer. We provide the correct answer as well. So now what we want the model to compare this to the correct sentence to the student answer, and based on this question we want a score and feedback. So what was the question? The question was what is the key contribution of the paper. Okay, this is the question. And what the student answered that it proposes using a more efficient attention mechanism, and the correct answer is a novel spare attention mechanism for transformers. So two answers similar, quite similar, but this spare thing is differentiating those two answers. Okay, so yes, what the model responded, let's see. The model responded the student answer is partially correct. While it identifies the attention mechanism is a key aspect, it misses the crucial details that the mechanism is spare. Yes, so the spare thing is missing from that student answer. So yes, that's why it gave the student answer a score 3 out of 5. So similarly, we also evaluated the model response as well. Okay, so that's why we crafted this summary prompt, and it has very detailed evaluation metric. We defined rating rubric, and we fed question and AI generated response. Now let's see how the model evaluates its own response. Okay, so that's why we fed a question like this question: what is the concept of lost Einstein, and what does the paper suggest about their potential impact? So this is the question, and we fed a wrong answer to see how the model actually performs. Okay, so this thing is done intentionally. So I did this thing intentionally. Like for this question, I put a wrong answer. This answer is for centrifugal force. So that has no connection to this question. Okay, so let's see how the model performs. So it gave the instruction following, like rating 1. So what does it says? Let's see. It said that the response does not answer the question about lost Einstein. Let's see. The groundness, here also the model said the rating 1. Okay, the conciseness also rating 1, but the fluency, but the response is nice. It follows all the grammatical rules, so that's why it gave 5 to the fluency. So overall rating is 1. So now let's see how it is performed for the correct answer. So this is the prompt text, and this is the correct answer this time. So for the correct answer, the model response is 5555 and overall rating is 5, because this is the correct answer. So in the model evaluation section, overall evaluation section, this model is also performing great. Okay, so the final part is the RAG implementation. So for RAG implementation, again we fed this knowledge base, our paper, and this time we splitted our document into smaller chunks, and we set the max character to 200, because as we will implement RAG, we will store the embeddings and the vector database to ChromaDB later on. So to improve the computational efficiency, we splitted the text or the document into manageable chunks. So from ChromaDB, we imported the embedding functions, and from the embedding functions, we use the Google Generative AI embedding functions using the Google API key from Kaggle Secrets, and we initialized the Chroma client and created a database, vector database in ChromaDB, and the embedding function is Google EF embedding function. Here we initialized that, and we added all the chunks, smaller chunks, to the database. And here the count of the database is 854, and we randomly picked one of the database, and let's see what are the embeddings. Here we can see all the embeddings here. Then we initialized this query, and the query text is what it says about child with good math score. So based on this query, we will search the vector database, and we want to see which passage is responsible for this query, particular query. Okay, so we did the same, and the response is this. So this particular passage is responsible for this query. So we did the same thing here using a prompt, and this is the basic retrieval thing or basic RAG implementation that will search a vector database like Chroma and gives you a particular output that is related to this query. So this is the basic RAG implementation. So that's all about the project. Thank you, and hopefully all you have enjoyed this project.